Welcome back. Once we know what is BIGO notation, it's time to calculate BIGO notation, and for that we need to have some rules in our mind. Let's see each one in detail. The rule number 1, always worst case. That means whenever we are calculating BIGO notation, we always need to have worst case in our mind. For example, suppose we have been given an array. In that array, we need to check whether this particular element exists or not. So it is possible that we may get that element at 0th index itself. But on the worst case, that element may exist at the end, the last element. So our BIGO notation will be O of n, not O of 1 if we will go by linear search. What is the linear search and all other things that we will see slowly. Then the next thing, remove constants. Suppose the same operation I am performing 4 times. So I will write 4 O of 1. But at that time, I will remove the constants and I will have the time complexity of O of 1 only. Once we are done with this, we can see rule number 3. Different inputs should have different variable. That means if there are two arrays and we don't know the size of an array, we should use different variable for them. O of A and O of B. Not O of n common for both the things. And if the things are in order one by one, at that time we will use plus sign. But if they are nested, we will use multiplication. Once we are done with this, we can drop non-dominant terms. So suppose we have O n square and O n cube. So we will remove O n square and we will consider O n cube only. So that is mean by non-dominant terms. Once we know the rules, it's time to do some practicals. So here, we need to simplify the following expression. So we have been given O of n plus 10. As our rule number 2 says, remove constant. So we will end up with O of n only. Simple? Yes. Next we have O of 25. As this is also the constant term, so we will remove this 25 and we will replace this 25 by 1. So we will have time complexity of O of 1 only. In our third example, we have been given O of n square plus O of n cube. But rule number 4 says drop non-dominant term. So O of n square is lesser than O of n cube. And that is much lesser than if we will talk about billions of the inputs. So surely we will drop O of n square and we will left up with the time complexity of O of n cube. Once we are done with this, we have something called as O of n plus n plus n plus n plus n 4 times. So we will write O of 4n and then we will be left up with only O of n as we will remove the constants by the rule number 2. So these all 4 golden rules are very important. Very important golden rules these all are. Once we are done with these things and we are clear with the concept, it's time to calculate the BIGO notation. Here we need to find out the BIGO notation of the below function. So one by one we will cover up each and every line. On the first line, we are executing the single step, let A is equal to 5. So for this line, our BIGO notation will be O of 1. Similarly, for the line number 2 and 3, it will be again O of n. And it is a single step process. Then we have the for loop, and inside that we are operating 3 operations. There we have O of n and again O of n because number of input we don't know. So we will simply donate it by n and we will perform this operation n times. So O of n will come. Similarly for the second for loop, again we don't know number of input to length. So we will donate each operation by O of m as we perform this operation m times. So O of m and O of n will come 2 times as there are 2 operations. After that we have let who am I is equal to I don't know. As this is a single operation, we will again write O of 1. Once we were done with this, we will simply add up all these things. So we will have something called as 3 into O of 1 plus 3 into O of n plus 2 into O of m. After simplifying this thing or removing the constant, we will have O of 1 plus O of n plus O of m. As we already know, we need to remove non-dominant term. O of 1 is very less, very small in size, so we will remove it. And then we will left up with O of m and O of n. And for our program, our BIGO notation will be O of m plus n. I hope with this example, our concept of BIGO notation is clear and we will be able to calculate BIGO notation of many more functions as we want. With this, it's time to see some more interesting question. So let's see. In this particular question, we have written a function log at most 10. There we are passing n as an input. Inside that we have written for loop and we have written I less than or equal to math.mean n comma 10. That means if n will be 25, then also this console.log I will be performed only 10 times because we are just wondering about the minimum value and we are just concerned about the minimum value, not the maximum value. Okay, so although the number of inputs reaches to the billion or the million, then also our time complexity will be constant as it will perform only 10 operations and not more than that. So in that case, our BIGO notation will be O of 1. Once we are done with this, it's time to see what if I will change this math.mean to math.max. So if I will change math.mean to math.max, at that time, suppose if n will increases to billion, so we will perform this operation billion time as we are worried about the maximum value. So in this case, BIGO notation will be O of n. With this, we have covered the maximum topics about the BIGO notation, how to calculate it. And if you want, we have site called as BIGO notation cheat sheet. There you can see some BIGO notation graph. It is shown that O of 1 is the best. Then we have O of n. Then we have O of n log n. Then we have O of n square, that is horrible for us. Then we have O of n 2 raised to n. So this all things we will see one by one and we will try to implement all these things in our example. Thank you very much for now. Let's meet in our next video tutorial with some more interesting funs. Thank you.